Hello all, welcome to Soumya Tutorials. Class BCA 5th semester CBCS syllabus analysis of designing algorithm. This is the session number 3, the chapter Introduction to Analysis of Designing Algorithm. So last class we had discussed about the concept of what is a stack, what are the different operations to be performed on the stack, and how the stacks are to be represented. It means by using an array representation or by using the linked list representation. So today we discussed about the concept of queue. So queue, it is an ordered list in which all insertion takes place at one end. That end is called as a rear end. This also we can call it as NQ, where all the deletions are takes place at another end. That end is called as the front end, and we can also call as DQ. In simply, a queue is an ordered list of an elements where elements are inserted at the one end and deleted at the another end. So that is we can call it as a queue. The operations of queue, it requires that the first element that is inserted into the queue, that element is first one to be removed. So that this process we can call it as the first in, first out. Thus, the queues are known as first in, first out. That means FIFO list. So Q is also called as the FIFO list. So this diagram which shows that the Q representation. So in the Q, it consisting of the elements 1, 2, 3, 4, 5. Elements are inserted at the one end. That end is called as a rear end. We can also called as a NQ. So right side ಅಲ್ಲಿ ರೇರ್ ಅಂತ ಕೊಟ್ಟಿದ್ದೀವಿ. ಸೊ ಅದ್ರ ಜೊತೆಗೆ ಆ ಪ್ರೋಸೆಸ್ ನೇಮ್ನ ನಾವು NQ ಅಂತ ಕರಿತೀವಿ. So that elements are to be inserted at the one end. That end is called rear end. That process is called as NQ. And similarly, elements are deleted at the another end. That end is called as a front end. That process we can call it as a DQ. So in the according to your syllabus, the circular queue concept is present here. So there are different types of the queues. The one is an simple queue. Second one, it is a priority queue. Third one, it is circular queue. Fourth one, it is double-ended queue. So ನಿಮ್ಮ syllabus ಅಲ್ಲಿ ಇರುವಂತ ಕಾನ್ಸೆಪ್ಟ್ circular queue only. And efficient queue representation, it can be obtained by taking an array, the queue of 0 to n minus 1, and treated it as if it is were circular. So that this queue representation, we can call it as a circular queue. Elements are inserted by increasing the variable rear to the next free position. When the rear equal to n minus 1, the next element is entered at the queue of 0 position in case that spot is a free. That means, so already ಎಲ್ಲ elements ಕೂಡ fill ಆಗೋಗ್ಬಿಟ್ಟಿದೆ. 0 position, 1 position, 2 position, up to n minus 1 position ವರೆಗೂ. So next ನಾವು front end, that is front position, queue of 0 ನಲ್ಲಿ element delete ಮಾಡಿದ ನಂತರ ಅಲ್ಲಿ ಏನಾದರೂ ಪ್ಲೇಸ್ ಖಾಲಿ ಇತ್ತು ಅಂದಾಗ ನೆಕ್ಸ್ಟ್ ಎಲಿಮೆಂಟ್ ನಾವು ಇನ್ಸರ್ಟ್ ಮಾಡಬೇಕಾದ್ರೆ ಆ ಖಾಲಿ ಇರುವಂತ ಪ್ಲೇಸಿಗೆ ನಾವು ಎಲಿಮೆಂಟ್ಸ್ ಅನ್ನ ಇನ್ಸರ್ಟ್ ಮಾಡಬಹುದು. ಸೊ ದಟ್ ಈಸ್ ದಿಸ್ ನೇಮ್. ದ ವೇರಿಯಬಲ್ ಫ್ರಂಟ್ is always points one position counterclockwise from the first element in the queue. The variable front equal to rear. If and only if the queue is an empty. So that we initially said the front and equal to rear equal to the 0, 1. the queue is an empty. So this is the diagrammatic representation of the two possible configurations for a circular queue that containing the four elements J1, J2, J3 and J4 with the n is greater than 4. So the first diagram, it represents the front position equal to 0 and the rear position equal to 4. So first 0 ಇಂದ ನಾವು ಎಲಿಮೆಂಟ್ಸ್ ಅನ್ನ ಇನ್ಸರ್ಟ್ ಮಾಡ್ತಾ ಡಿಲೀಟ್ ಮಾಡ್ತಾ ಬರ್ತಾ ಇದೀವಿ. ಸೊ ಫೋರ್ತ್ ಪೊಸಿಷನ್ ಗೆ ರಿಯಲ್ ಎಲಿಮೆಂಟ್ ಲಾಸ್ಟ್ ಆಗಿದೆ ಫಸ್ಟ್ ಡಯಾಗ್ರಾಮ್ ಅಲ್ಲಿ. ಸೆಕೆಂಡ್ ಡಯಾಗ್ರಾಮ್ಯಾಟಿಕ್ ರೆಪ್ರೆಸೆಂಟೇಷನ್ ಅಲ್ಲಿ ಆಲ್ರೆಡಿ ಫಸ್ಟ್ ಸೆಕೆಂಡ್ ಥರ್ಡ್ ಫೋರ್ತ್ ಅಲ್ಲಿ ಎಲಿಮೆಂಟ್ಸ್ ಫಿಲ್ ಆಗಿತ್ತು, ಮತ್ತೆ ಕೂಡ ಅದನ್ನ ಡಿಲೀಟ್ ಮಾಡಿದೀವಿ. ನೆಕ್ಸ್ಟ್ ಈ ಕಡೆ n-3, n-2, n-1 ಅಂಡ್ 0 ಪೊಸಿಷನ್ ಗೆ elements ಮತ್ತೆ insert ಆಗಿದೆ J1, J2, J3 and J4. So here the rear position is a 0 and the front position it is an n minus 4th position. So when we have to inserting the one more element into this circular queue that is inserted at the position 1. That means the rear pointer is increment by the 1, then inserting an element at the 1th position. So that is the next example ಅಲ್ಲಿ ನಾವು ಒನ್ ಬೈ ಒನ್ ಎಲಿಮೆಂಟ್ಸ್ ಯಾವ ರೀತಿ ಎಂಟರ್ ಆಗುತ್ತೆ ಅಂತ ಹೇಳ್ತೀನಿ. ಸೊ ಇಲ್ಲಿ ನೋಡಿ, ಸೊ ಇದಿಷ್ಟು ಕೂಡ ಪ್ರೋಸೆಸ್ ಆಫ್ ದ ಎನ್ ಕ್ಯೂ ಅಂಡ್ ಆಲ್ಸೋ ದ ಡಿ ಕ್ಯೂ. ಸೊ ಇನ್ ದ ಫಸ್ಟ್ ಡಯಾಗ್ರಾಮ್ ನೋಡಿ, ಇಲ್ಲಿ ಪಾಯಿಂಟರ್ ತೋರಿಸ್ತಾ ಇದ್ದೀನಿ. ಸೊ ಈ ಪಾಯಿಂಟರ್ ಅಲ್ಲಿ ಫಸ್ಟ್ ಸರ್ಕಲ್, ಈ ಪಾಯಿಂಟರ್ ಅಲ್ಲಿ ಹೈಲೈಟ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ ನೋಡಿ ಇಲ್ಲಿ. ಸೊ ಫಸ್ಟ್ ಸರ್ಕಲ್ ಅಲ್ಲಿ the first it initially the front is equal to 0 and also the rear is equal to 0. So e process the nq, which means inserting an element into the queue, that process is called as nq. So ಇಲ್ಲಿ 14 ಅನ್ನೋ ಎಲಿಮೆಂಟ್ ಅನ್ನ ಫಸ್ಟ್ ಪೊಸಿಷನ್ ಗೆ ಇನ್ಸರ್ಟ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ಸೊ ರೇರ್ ಎಂಡ್ ಮುಖಾಂತರ ದ ಫಸ್ಟ್ ಎಲಿಮೆಂಟ್ 14 ಅನ್ನೋ ಎಲಿಮೆಂಟ್ ಅನ್ನ ಇನ್ಸರ್ಟ್ ಮಾಡ್ತಾ ಇದೀವಿ. ಅಲ್ಲಿ ರೇರ್ ಕೂಡ ಅಲ್ಲೇ ಇದೆ, ಫ್ರಂಟ್ ಕೂಡ ಅಲ್ಲೇ ಇದೆ. Then the second diagrammatic representation of the circle, here nq, that means inserting an element into the queue. So here the 22 ಅನ್ನೋ element ಅನ್ನ insert ಮಾಡ್ತಾ ಇದ್ದೀನಿ. So ಇದರಲ್ಲಿ the rear which is incremented by the point 1, then inserting an element into the queue. So 14 0 position ಅಲ್ಲಿದೆ, 22 1 position ಅಲ್ಲಿದೆ ಅಂತ ಅನ್ಕೊಳ್ಳಿ. Next, the one more element is inserted into the queue, that is a 13. So that means the rear is incremented by the 1, then 13 has to be inserted into this queue. Then the one more element is inserted, that is a 6, 14, 22, 13. Then the 6 is also inserted into the queue. Then we move on to the next circle. So ಇವಾಗ 14 ಇದೆ, 22 ಇದೆ, 13 ಇದೆ, -6 ಇದೆ. ಇವಾಗ ರೇರ್ ಪೊಸಿಷನ್ -6 ಹತ್ರ ಇದೆ, ಫ್ರಂಟ್ ಪೊಸಿಷನ್ 14 ಹತ್ರ ಇದೆ. ನೆಕ್ಸ್ಟ್, ಸೊ ದ ಪ್ರೊಸೆಸ್ ಆಫ್ ಡಿ ಕ್ಯೂ ಹಿಯರ್, ಇಲ್ಲಿ ಎಲಿಮೆಂಟ್ಸ್ ಅನ್ನ ಡಿಲೀಟ್ ಮಾಡ್ತಾ ಇದೀವಿ. ಇವಾಗ ಫಸ್ಟ್ ಯಾವುದು ಎಂಟರ್ ಮಾಡಿದೀವಿ ಆ ಎಲಿಮೆಂಟ್ ಡಿಲೀಟ್ ಆಗಬೇಕು. ಸೊ ದಿಸ್ ಇಸ್ ಫಸ್ಟ್ ಒನ್, ಫಸ್ಟ್ ಇನ್ ಫಸ್ಟ್ ಸರ್ವ್ ಬೇಸಿಸ್. ಸೊ ದಟ್ ಈಸ್ ದ ಫಸ್ಟ್ 14 ಅನ್ನು ನಾವು ಇನ್ಸರ್ಟ್ ಮಾಡಿದೀವಿ, ಅದೇ ಎಲಿಮೆಂಟ್ ಡಿಲೀಟ್ ಆಗಬೇಕು ಡಿ ಕ್ಯೂ ಪ್ರೋಸೆಸ್ ಅಲ್ಲಿ. ಸೊ ಫಸ್ಟ್ ಡಯಾಗ್ರಾಮ್ಯಾಟಿಕ್ ಇಲ್ಲಿ ಡಿ ಕ್ಯೂ ಆಪರೇಷನ್ಸ್ ಅಲ್ಲಿ 14 ಎಲಿಮೆಂಟ್ ಈಸ್ ಡಿಲೀಟೆಡ್. ನೆಕ್ಸ್ಟ್ go to the next circle. So here also DQ operation ಅನ್ನ perform ಮಾಡ್ತಾ ಇದೀವಿ. The next element ಇದ್ದಿದ್ದು 22. That element is also deleted. Next go to the next circle. Here ಇಲ್ಲಿ NQ ಮಾಡ್ತಾ ಇದೀವಿ, ಎಲಿಮೆಂಟ್ಸ್ ಅನ್ನ ಇನ್ಸರ್ಟ್ ಮಾಡ್ತಾ ಇದೀವಿ. ಸೊ ನೆಕ್ಸ್ಟ್ ಪೊಸಿಷನ್ ಗೆ 9 ಅನ್ನೋ ಎಲಿಮೆಂಟ್ ಅನ್ನ ಇನ್ಸರ್ಟ್ ಮಾಡ್ತಾ ಇದೀನಿ. ನೆಕ್ಸ್ಟ್ ಅಲ್ಲಿ ಎಲ್ಲಾ ಎಲಿಮೆಂಟ್ಸ್ ಫಿಲ್ ಆಯ್ತು. ನೆಕ್ಸ್ಟ್ ಮತ್ತೆ ಒನ್ ಮೋರ್ ಎಲಿಮೆಂಟ್ 20 ಅನ್ನೋ ಎಲಿಮೆಂಟ್ ಅನ್ನ ಇನ್ಸರ್ಟ್ ಮಾಡ್ತಾ ಇದ್ದೀನಿ. ನಾವು 14 ಅಂತ ಏನ್ ಡಿಲೀಟ್ ಮಾಡಿದೀವಿ ಫಸ್ಟ್ ಪೊಸಿಷನ್ ಎಲಿಮೆಂಟ್, ಅಲ್ಲಿಗೆ ಸ್ಪೇಸ್ ಖಾಲಿ ಇತ್ತು, ಹಂಗಾಗಿ ದ ರೇರ್ ಈಸ್ incremented by the 1, then element are to be inserted at this position. 20 ಅನ್ನೋ ಎಲಿಮೆಂಟ್ ಫಸ್ಟ್ ಪೊಸಿಷನ್ ಗೆ ಇನ್ಸರ್ಟ್ ಆಯ್ತು. Then go to the next circular queue. So here ಇಲ್ಲೂ ಕೂಡ NQ operations perform ಮಾಡ್ತಾ ಇದೀವಿ. So next element 5 element ಅನ್ನ insert ಮಾಡ್ತಾ ಇದ್ದೀನಿ. So that is the 5 is the element that is inserted at the position number 1. So ಈ ರೀತಿ circular queue operate ಮಾಡುತ್ತೆ, operations perform ಆಗುತ್ತೆ. So this is the algorithm for the insertion algorithm. Addition of a new element into the queue. So first algorithm name is that add queue within a bracket, one parameter are to be present, that is item. Insert item in the circular queue stored in the queue 0 to n minus 1. The rear points to the last item and the front is the first position in the counterclockwise from the first item in the queue. So first here the rear is equal to rear plus 1 mod n. This indicates that advance is clear clockwise or it is an anti-clockwise. So that is first we have to checking the advances rear clockwise direction. So then we have to checking the one more condition. If the front equal to rear, if the front which is equal to rear, when this condition is become true, the queue is at the full. Then the one more conditions are to be present here. If the front equal to 0, then the true statement is rear is equal to n minus 1. That is the last position. Or else the rear is equal to rear minus 1. That means move rear one position in the counter clockwise. ಅದರ ಹಿಂದೆಗಡೆ ಪೊಸಿಷನ್ಗೆ ಒಂದು ಕಡಿಮೆ ಆಗಬೇಕು ಅಂತ. So it returns a false. Or else Q ಅಲ್ಲೇನು full ಆಗಿಲ್ಲ ಅಂತಂದ್ರೆ then ಅಲ್ಲಿನ್ನು place ಇತ್ತು ಅಂತಂದ್ರೆ we have to incrementing the rear pointer, then inserting an element into that rear position. So that is the statement, the item equal to Q of rear. Here is that we have to inserting the new item into the existing queue. It returns the true. So this is all the process we can call it as addition of an element into the queue. Then the next algorithm is deletion algorithm. Here is the delete queue within a bracket. Parameter name is item. It removes and returns the front element of queue, the queue of 0 to n minus 1. The first it checks whether the front equal to rear. When this condition is become true, the queue is an empty. Or else ಅಲ್ಲಿ ಕ್ಯೂ ಎಂಟಿ ಆಗಿಲ್ಲ ಅಂದ್ರೆ ಏನಾದ್ರೂ ಎಲಿಮೆಂಟ್ಸ್ ಇರುತ್ತೆ ಅಂತ ಅರ್ಥ. ಸೊ ಆರ್ ಎಲ್ಸ್, so go to the next statements here. Front is equal to front plus 1 mod n, which means that advances front clockwise direction. So item equal to the queue of front, ಆ ಪೊಸಿಷನ್ ಇರುವಂತ ಎಲಿಮೆಂಟ್ ಅನ್ನ ಕಾಪಿ ಮಾಡ್ಕೋಬೇಕು. So then it is to be deleted. Set that item to the front of the queue, then it is deleted. So then returns true. So this is the algorithm for the deletion of an element in existing queue. Then go to the next slide here. The concept is that trees. So what is a tree? A tree is a finite set of one or more nodes such that there is specially designated node that we can call it as a root node, and the remaining nodes are partitioned into the n which is greater than or equal to the 0. That are all the disjoint set, that means T1, T2 up to Tn positions, where each of these sets it is a tree. The set T1, T2 up to the Tn are that are all we can call it as the subtrees of that root node. In simply, the definition is that a tree it is a finite set of the one or more node such that there is a specially designated node. It is called the root node, and the remaining nodes are called as the other nodes or a child nodes. One more definition is also there. A tree is a hierarchical data structure defined as a collection of nodes. The node is represented the value or and the nodes are connected by the edges. So in other words, the tree is a nonlinear data structure and the hierarchy consisting of a collection of nodes such that each node of a tree stores a value and a list of references to the other nodes. That node we can call it as a child nodes. So this is a diagrammatic representation of the tree. The tree, it contains the number of terminologies are present here. The first is a root node, and the root node and the another node, that is a P to an R, that is we can call it as a edge. The topest node we can call it as a the root node. Then the height of the tree, that means level 1, level 2, level 3, level 4, level 5. So the height of the tree, it is a level 5. So then siblings. The two children are coming from the same parent. That all we can call it as a siblings. Then parent. So here one example, E, F, G, that three are the children. So that parent name, it is a L. So the last is the leaf node. H and I, these are all the leaf node. So that is parent is M. The first terminology here is root node. What is the root node? The topmost node in a tree, it is called as the root node. Then one more term, it is height of the tree or the degree of a node, which means that the number of the subtrees of a node, it is called as the degree of a node. And the height or the depth of a tree, which means that the maximum level of any node in a tree, that we can call it as a height of the tree. We can also call it as a depth of the tree. So in the example, ನಮ್ಮ example ಅಲ್ಲಿ height of the tree ಆಗಿರ್ಬೋದು, depth of the tree ಆಗಿರ್ಬೋದು, level 5. The next, leaf or terminal node. What is a leaf node or what is a terminal node? The node that have a degree 0. That role we can call it as a terminal node or a leaf node. Last nodes ಏನಿರುತ್ತೆ ಅಂತ ನೋಡ್ಸ್ಗೆ ಅದರ ನೆಕ್ಸ್ಟ್ ಮತ್ತೆ ಯಾವುದೇ ನೋಟ್ಸ್ ಡಿರೈವ್ ಆಗಿರಬಾರ್ದು ಅಂತಹ ನೋಟ್ಸ್ಗೆ ಲೀಫ್ ನೋಟ್ಸ್ ಅಂತ ಅಥವಾ ಟರ್ಮಿನಲ್ ನೋಟ್ಸ್ ಅಂತ ಕರಿತೀವಿ. ನೆಕ್ಸ್ಟ್, ಚೈಲ್ಡ್ ನೋಡ್. The roots of the subtrees of a node that doesn't have any child nodes, that we can call it as a child nodes. Next, what is a parent? Every children that has one parent, that node we can call it as a parent node. In our example, the L is a parent. The next is siblings. The children of the same parents are called as the siblings. So in our example, A and B are the siblings of a parent Q. So these are all the some of the terminologies of the tree. So these are all the definitions. Thank you. If you like my videos, please do subscribe to my channel and click on the bell icon for the notification of the new videos. Thank you so much.